Is it important? Is downtime important?
Yes, downtime will cost you some loss, but how can we avoid that?
Let's Sembang AIoT. Hi, good morning, good afternoon, and good evening, wherever you are. So, welcome, and also welcome you back. I mean, and also welcome you guys to watch the Let's Sembang AIoT this round. I think we want to take this opportunity to wish all our fellow Malaysian who is Muslim, who is celebrating the Hari Raya, Aidilfitri. Selamat Hari Raya.
Yeah, Selamat Hari Raya.
I'm Cecily here, and then we are regularly doing this live on every Friday and 4 o'clock. In the afternoon. So this episode is a very special episode. It's something that is extended from the past episode. I think last week we were on the 43. So this one with the 44. Yeah, 44. So 44 actually is a very good number for most of the our Malay friend. Malay friend. Empat. So dapat lah. A lot of people say empat. So wish you a prosperous Hari Raya this round. Dapat a lot of this ketupat also. Yeah. So wish you a nice holiday and also a good celebration for this Hari Raya. So this episode, we will be talking about the downtime. Yeah, downtime. This morning we just had a very good discussion with one of our partners. So they were talking about this plastic industry. If you are in the plastic industry, maybe you can share some view or you can give us some comment. In fact, we are talking about AI, we are talking about IoT, on the data collection, and on vision AI and things like that. So for this part, we want to extend something from here because they were talking about this plastic injection. There's some screwing thing in and out. Those thing is running 24/7 sometime. Without running on a shift. So things will wear off. The component failure and so on. So how can you prevent of this unplanned downtime? Yeah. How can you minimize this kind of unplanned downtime? Because when this what they call the downtime, what will cost them? Basically, how would that be?
What would cost the unplanned downtime?
Yeah.
When the unplanned downtime happen, your production, your productivity will decrease.
Yeah, of course. Yeah.
And then the good that need to deliver to a customer will be delayed.
Yeah. Yes.
And then if sometimes when delay happens, sometimes maybe customer will sue you.
Okay, customer will make a lot of this complaint.
Yeah.
So I mean the impact for the downtime is great sometimes. That's why in most of the factory operation or in some of the process, they have this so-called schedule maintenance. Schedule maintenance meaning the kind of preventive maintenance, right? Preventive maintenance. Because you're talking about just now, we're talking about this kind of a process like plastic injection or motor running and so on. So these are the things that usually things will wear off one. If there's a lifetime, it will break down in without your knowledge, without even you think about it. So this thing can break down. Once this break down, your machine there will be a downtime. So this is also very relevant to some of our topic that we cover, like OEE. OEE in some of the process like plastic, like CNC machines, like in the electronics industry. These are the industry that rely on the OEE data to judge whether your machine utilization and also how efficient the process is being run. Yeah. So today we want to bring back the last week what we have done. We have this kind of sensor. In fact, for a process, maybe I want to ask, for a process to fail, or for a component or some machine to fail, usually there are several criteria or several parameters that cause this thing, or some of these parameters will give you some indication, whether or not your this equipment is still healthy or not. Yeah. So one of them is vibration.
Yeah.
So totally, roughly, how many of them? For example, one of them is vibration. How do we use this vibration data again?
Okay, so usually the vibration sensor will give you the amplitude, velocity, acceleration. Some of them give you the displacement, and then the frequency. And all these things can come from different axes. For example, this sensor provides 3 axes. So you have the x-axis amplitude, y-axis amplitude, z-axis amplitude.
Okay, these are the parameters. So can you elaborate a little bit more? What are these kind of parameters that will give you a hint, or will give you a kind of a sign that the equipment is going to fail soon?
So let's say, for example, in this case, we are measuring the vibration of a fan.
Yeah.
So when the fan is running at full speed, it will have certain vibration.
Yeah.
So when the fan is going to fail, the speed of the fan will become slower. Then the vibration might reduce. It can be reduced, or in opposite way, the vibration become much more greater than the normal condition.
Or sometimes inconsistent of speed.
Yes. Sometimes the fan
jogging, something like
sometimes
that.
fast, sometimes slow. So the vibration also inconsistent in that case. So all these scenarios will give you the sensor value that can help you to identify at what time the abnormal start occur.
So that is a part of anomaly detection. For those of you who didn't, who is first time watching this one, you can refer to our past. We also touched a little bit on this predictive maintenance, some sensors. That time we are running it live. Yeah. So this round, I think we are going to touch this part in our final round. This part we didn't turn it on. We just want to explain to you how this thing, we are going deeper on how to do this part with the AI or with the current IoT. So in terms of IoT side, what are the component that we use in order to do data capturing first?
Okay. Yeah. For this case, we have a 4G gateway that can do the multi-pass pooling. So usually most of the sensors that support the RS485 or the multi-pass TCP. So we can use the IoT gateway to do the multi-pass pooling to get the data.
Just want to interrupt a little bit now, because last week we show we are using the Axiomtek IoT gateway and the edge gateway to perform the data collection as an edge. But for this guy, this guy is a 4G gateway router, which is more kind of a more dummy device, but it can do all this kind of data collection very well. Yeah. So this part has the two publishing channel. One of them is can publish MQTT. You can publish a REST API. It can be direct to the cloud, and also it can go on to direct to the on-prem kind of server or edge server or fog node or something like that. If you know, if you follow our this fog computing side, we will talk about this on fog node and so on. So that part is on the IoT side. But what about we use IoT? We use an IoT device or a gateway to collect all this data, and then on the AI side, on the AI side, what does this what you call the vibration sensors? How are you going to deal with this part? Let's say for a person who who want to look into this using the AI technology.
Okay. So first, before we apply the AI, so let's say we don't have the AI technology, so you need someone who are very experienced, very know the pattern or the working principle of the sensor. Then based on that guy experience, then he will tell you, okay, based on the pattern of the graph, then the abnormal occur. But sometimes when you have a lot of parameter to monitor, it's very hard to identify whether the abnormal occur or not. If you have multiple, for example, 10 or 20 parameter, then you have 20 graphs to monitor at the same time. So it's very hard for you to give a judgment that the abnormal already occurred. So in this case, we might need the help from the AI. For example, in this case, we can use the machine learning algorithm. There are a lot of machine learning algorithms that can help you do the anomaly detection, or we call it outlier detection algorithm. So it will detect those sensor value that it has abnormally.
Outlier. How do you spell outlier?
OUTLIER. Outlier.
Outlier.
So something that is not within the normal range.
It's a kind of naming to the AI, machine learning AI.
Outlier, I think, is a term very common in the statistic.
Okay.
When you plot the histogram.
Can I say some of this machine learning, AI machine learning, is basically a kind of a statistical kind of a method involved in the whole thing?
Yes. The fundamental is of
like Six Sigma, all this thing. Okay. Interesting. Yeah.
So we can use the AI to help us to make the judgment whether the abnormal occur or not. When you have multiple parameters need to be monitored at the same time.
I see. So that's why talking about this AI part, I noticed just now you mentioned about if without the AI, what you are going to do is you are going to do a lot of this monitoring at the different parameter, different graph. So that is a very tedious work, and then some more, it may not be so easily automated. But if you fit it to the black box, the AI black box, so that they will do like a kind of intelligent for you, that's a human that's keep on watching, so you will be able to differentiate, with the kind of methodology that apply, like this kind of statistical thing, in the machine learning AI or things like that. Okay, that's a way, yeah. Of course, 𝐀𝐩𝐫𝐢𝐥 has just mentioned about this part. Just now you mentioned about this domain expert. This maybe is more relevant to, let's say, for a motor or the injection thing. That they're performing. Maybe it's driven by an actuator. This actuator has got some parameter to judge whether some anomaly happen. This thing is going to die soon. Something like that. It may be also a kind of a pump rotating thing in the ball bearing. If let's say one of them wear off, so it give you some different vibration. That part is one of the key parameter for this vibration. So the second part of the parameter that usually that will be taken into consideration are like temperature. Certain thing go heat up because of what they call not vibration. That is called what?
The friction.
The friction. Yeah, the friction. Give you more. The temperature will go higher, or even the motor current. The current consumption. The current. So something will give you more friction, or it will be like things want to jam up already. The current thing will be shooting up.
You draw more current.
So practically, because we are talking about in the AI era, what are the commonly used model? For example, last week we show how many of them?
Last week I think a lot. Last week we show the isolation forest.
Isolation forest. Is isolation forest a kind of a model that created by someone, or is it a generator?
It's a machine learning algorithm.
It's one of the machine learning algorithms. That means isolation forest can be can be created by different personnel or different expert in different fields, is it?
Yes, as long as they follow the step in the algorithm, then you can recreate the algorithm using different language.
Is there, because last week also we mentioned about this AI, machine learning. Is there a deep learning version of this isolation forest?
We can say we have a deep learning version of this anomaly detection.
So anomaly detection govern the whole thing about. So they don't call it what they call the isolation forest anymore.
No.
So maybe inside they apply something like that.
The way totally different already when we go to deep learning.
So that means deep learning, will they be using same kind of statistical methodology again or more?
In deep learning, they were more focused using the neural network.
Neural network. Neural network is something that you are going to train them.
Yes.
You are going to train them. Of course, you are going to tell them which part is abnormal. Do you need to tell? No, this is unsupervised.
Okay, yeah. If you are using the unsupervised deep learning, then you don't need to tell.
So my unsupervised deep learning can be monitoring 10 parameter or 20 parameter. Can I say?
Yes.
So it can be done that way. Okay, as what we mentioned also. If you have a time, we will show you some of the example. Probably, if possible, we can do it live We can do it live. We will find something, so you can experience, or we can share some of this experience to you. So for those of you who just watched us, thank you very much for watching. If you find this video or find this information relevant to you, do like, share, and subscribe. Yeah. So me and Cecily and 𝐀𝐩𝐫𝐢𝐥 is we are doing this live for you every Friday 4 p.m. So now we want to jump to the other area, because we have been doing, I think 𝐀𝐩𝐿 has been involving in a lot of this machine learning, deep learning, AI in vision and so on. Yeah, we have done several things. There is one term that we call AIoT xConnect. Yeah. So this is from Axiomtek and also from this AIoT mission. We have this AIoT xConnect. X factor meaning we applying AI and IoT with the customization of the thing that you want. AIoT xConnect meaning, if let's say you want to have a vision looking at, let's say, what do you call? There's one case we just want to share. There's one case. Let's say there is on the river. A lot of these those are trash and those are sampah, coming to the what do you call, on the river is clogging up already. You can use this one. So what we are going to have our AIoT xConnect is the X factor is to do the thing that you want. We use a deep learning model to train up, and then you can have the device to perform the thing that you want. So from there, what will in this xConnect box, what can we offer them as an interface? Yeah.
Interface means
like what kind of API that they call?
Usually we provide the MQTT, the RESTful API. These two are the most common.
So for you to publish those to the cloud, and also you can link to the server. So I just want to come back to the next topic today, is more on to the quality control, especially for smart manufacturing quality control. Vision, what can we do deep learning AI vision in this smart manufacturing?
Most common one is the defect detection.
Defect detection. Okay, so defect detection. So of course, when we talk about defect detection, there is another level of AI where it involves this kind of machine learning, and also can be another deep learning AI that actually coming from the sensor data, not so much of the image data, not so much on the video data, but it's more from the sensors. So that is AI within AI. Yeah. So in this case, how does this whole thing happen?
Okay. So let's say you are using the deep learning to perform the vision inspection on your product, and you found that there is a defect on it. Usually we want to trace it back. What causes the defect? So since we already installed some vibration sensor, temperature sensor along the production line, so we might want to retrieve those sensor value to identify whether is there any relationship between the defect and the sensor data or not.
Okay. So the sensor data, for example, one of the example is those plastic or some super material, which we have seen some of them. They collect from those recycle thing, but then they can produce things like material for 3D printing. Or the 3D printing is a very expensive thing, so it's very valuable. So in order to catch up to that kind of level, the quality control is very important. Yeah. So in order to do that, certain parameter, for example, in this case, the vision, deep learning vision AI, detected something, is happening. But at the same time, our IoT gateway is able to collect, for example, pressure, temperature. These are some of the process data, when you want to do forming of this kind of plastic. I don't know whether it's called plastic or not. It's considered a plastic or ceramic or something like that. Yeah. So that material is actually that come out from the process is very valuable. But then the quality of that is depending on the temperature and temperature and the pressure, let's say. So in this case, how AI is able to fit into this process.
So usually we need to collect a lot of temperature and the pressure data, and then let the AI to learn. In the normal working condition, what are those value for the temperature and the pressure? And then when the AI detect the defect on your end product, so then you need to look it back at those sensor value. So see, is there any abnormal in the sensor value or not? So if yes, then it might become one of the factor that caused the defect. But if no, then we can eliminate those factors and we look for other sources that might contribute to the defect.
Okay. So coming to AI question again, so what kind of AI or model that being used in this thing? Is it kind of isolation forest? Is it still apply?
Yeah, isolation
forest is
it's one of the choices.
Some deep learning AI thing also can be applied. It depends on which one you are using. What about let's say don't talk about this AI. People just use the statistical data to do something. What is the difference? Let's say I'm collecting data, I'm just plotting the chart using the statistical model. Is it same thing as what we do as AI?
Almost same, but it's not automatic. You need someone to plot it, and then someone to see whether is there some outlier appear in your graph or not.
Okay. So the beauty thing about the AI is there is a continuous process of watching or the detecting and analyzing the whole data line. Okay, I think if you have any comment or at all, please do give us a comment. I think this round we are going to do it as short because it's a festive season for our Muslim friends. And is there any more thing, you want to say something? No. So if there's none, so we want to wish all of you, who celebrate the Raya, or those people who is on a holiday, happy holiday and Selamat Hari Raya, and enjoy. And we'll see you in the next session. See you. Bye-bye.